Okay, let's go through the proof of Hopital's rule. Suppose that you have some function, f of a, and another function, g of a, and they're equal to each other, and they equal 0. And that the derivative of f of a and the derivative of g of a exists. Remember that the derivative of f of a would be the limit of f of x minus f of a as x goes to a, as x approaches a, all over x minus a. Then, L'Hopital's rule concludes that if you have the limit as x approaches a of f of x divided by g of x, that's going to be equal to the limit as x approaches a of the derivative of f of x all over the derivative of g of x. So this is what we're trying to prove. I'm starting with this suppose. To prove, we're going to work backwards. So working backwards from f prime of a and g prime of a, which are themselves limits. It's the definition of the derivative using limits. We have, by the definition of derivatives, notice that the derivative of f prime of a would be the limit as x approaches a of f of x minus f of a all over x minus a. G prime of a also would be the limit as x approaches a of g of x minus g of a all over x minus a. So you can see here, if we simplify this, these go away. And then, since we just have the same limit here, we can just write it like that. So this goes away. So now we have this. And now, we already know that these guys are equal to 0. So then we end up back at this. This basically proves that this is equal to this. Okay, and we already went through this, but notice, let's say we had this limit. The limit of 2x squared minus 2 all over x plus 1 is x approaches negative 1. So we can't do direct substitution there because you'd have 0 in the denominator. So this should be equal to the derivative of these functions based upon L'Hopital's, which would be the limit of 4x over 1 as x approaches negative 1. So this would be equal to negative 4. Another way to look at this, if we look at this original function and try direct substitution at x is negative 1, this would be the red line right here. Well, that point there is undefined. Okay? Notice that when we took the derivative of this function, we got this function. So that would be here. The function is slightly different than the original function. But now when we plug in g of 1, when x is 1, we can figure out that that's going to be negative 4. Okay, notice direct substitution is indeterminate. Okay, so if we tried direct substitution for this problem, the limit of, so let's say f of x equals e to the 2x minus 1 all over x, and if we tried direct substitution, we'd get e to the 0 power minus 1 all over 0, which would be 1 minus 1 over 0, which would be 0 over 0, which is indeterminate. So since that doesn't work, what we can do, we can try L'Hopital's. So the limit of this function as x approaches 0, if we take the derivative of this would be 2e to the 2x. The derivative of negative 1 would be 0, and the derivative of x would be 1. So now, if we took this function and we tried direct substitution, we would end up getting 2. Alright, taking a look at this one, the limit of the natural log of x all over x as x goes to infinity. So first of all, the function x this would be y equals x. The natural log of x would look something like this. Notice, as x is going to infinity, as x goes to infinity, y sub 1, or the natural log of x, will go to infinity. Here, this would be as x goes to infinity, y, or the function x, would be going towards infinity as well. So this would give me infinity over infinity, which is indeterminate, which means we need to take the derivative of each of these functions. So this would be 1 over x, this would be 1, which is equal to the limit of 1 over x. And now as this goes to infinity, this is going to be equal to 0, because think of this as being 1 over a million. And then 1 over a billion. Well, as this increases without bound, this number here is getting closer and closer to 0. All right, example 3. Evaluate the limit as x goes to negative infinity of x squared over y to the negative x. So, this would be y to the e to the x squared, look like that. So, as x goes to negative infinity, and be out this way, x squared would go towards positive infinity. Okay. Let's make this function here would be e to the negative x. So notice here, as x goes to negative infinity, e to the negative x would go to positive infinity. So this is going to be positive infinity over positive infinity. So we're going to use L'Hopital's rule. We're going to take the limit as x approaches negative infinity. And we'll take the derivative of x squared, which would be 2x, all over the derivative of e to the negative x, which would be negative e to the negative x. Okay. Now when we evaluate the limit, as x approaches negative infinity, or this would be, I need negative e to the x, which would be like this. This would be negative e to the negative x. And now as x goes to negative infinity, negative e to the negative x would go to negative infinity. So the top part here, or I guess the denominator is going to be negative infinity. Here is the line y equals 2x. So if x goes to negative infinity, this 2x would go to negative infinity. So that still would be indeterminate. So now we got to use L'Hopital's rule again. If I take the derivative of this would be 2. If I take the derivative of this is going to be positive e to the negative x. This would stay the same, x to the negative infinity. So here, this ends up becoming positive infinity. This ends up becoming just 2. So this really equals 0. So we don't need to write this.